A very good morning. My name is LING PEI SHI and my metric number is B0919102994. I'm from FTChem P3 BMMA section 1-2. Today, I would like to present about my final year project topic, which is experimental study of heat transfer performance across open cells metal form radiator. And this is the contents that I have created for these slides. And let's start with our introductions. As we know, car radiator is used to eliminate the excess heat generated by the vehicle engine to protect the inner rotating components from overheating. And it is usually located in front of the engine compartments with the coolant reservoir beside of it. And this car radiator, which is the conventional radiator, is run by some basic components such as thermostat, water pump, hoses, fan, pressure cap, and coolant. And heat transfer has direct relationship with the airflow and the coolant flow rate. Next, and this is our problem statements. So if your car is creates extreme heat or extreme temperature, it will result the engine overheating, high fuel consumption, and the most obvious impact is reduce the usage of the engine life rapidly, which lead to high payment maintenance fee. And nowadays, the planned fit type of the radiator was not longer fulfill the demand for more powerful engines in smaller hood space has created a problem of insufficient rates of heat dissipation in automotive radiator. So to minimize the stress on the engine as a result of heat generation, automotive radiator must be redesigned to be more compact while still maintaining high levels of heat transfer performance. So it means that we want to create a radiator in smaller size but still can perform a very high heat transfer performance to cool down the engine rapidly. The objective of this research is to redesign the open cell form radiator by replace the fins, and to produce the open cell form radiator using additive manufacturing methods. And the last one is to investigate the heat transfer performance of the form radiator. So let's move on the scope study of this project. So the model of the radiator that will be used in this study is conventional radiator model 850 as the preliminary research. And the coolant we use in this cooling system is water. And the foam is fabricated using 3D printer sintering laser and coated with the conductive spray and cut the foam into the pieces to replace the fins that attach to the radiator frame. And the last one, heat transfer coefficient, nozzle number, and its heat transfer efficiency will be studied on in this project. Okay, I will move on to literature review. So I will briefly explain about the heat transfer performance of open cell metal form car radiator, and this is some of the main points of some literature. So the first point is the study about the porosity, pore size, and the heating direction of the copper form. And this experiment is set up using the test rig. The difference of this experiment is the heat source is from the sides and the bottom. From the result shows, the different heating direction does not affect the heat transfer performance. In addition, higher porosities meaning higher permeability, which allows the fluid easier to flow through. One study is used the X-ray imaging and the specific software to produce the 3D metal forms with various porosities and PPIs, which is pores per inches. The result shows that the heat transfer coefficient is increases when increase the porosity, but does not increase with pores per inches due to the metal form with higher pores per inches has more specific surface area than foam. Another study is doing the numerical simulation using the NC fluent to study the forced convection heat transfer and to find the effect of foam thickness in the aluminum foam. And the numerical result it shows that the thicker the foam, the higher the heat transfer coefficient, which means it is easier for the heat to transfer to the outer space. This is because a larger specific area has the potentials of greater heat transfer coefficient. So that's why the heat transfer will be good when the specific area is greater. For the last point is the copper foam with 15 pores per inch under different heating power and air velocity to investigate the thermal characteristic and flow behavior of the heat transfer between the condensed section of heat pipe and the ambient air. The setup of the experiment is using the wind tunnel. However, the way to connect the metal form between the heat pipe becomes a challenge due to the low welding skill. And this is because the connecting method causes the thermal contact resistance affect the heat transfer performance. Next is Chapter 3 Methodology. Okay, this is my flow chart. So I will start with literature review and then redesign the radiator frame. And next we will reproduce the open cell form radiator and we will test run and we will proceed to experiment, result, and validation, analysis, conclusion, and the end. So this is the size of the form that I have created to insert into the car radiator. And this form I'm resize in the blender. After resize, this is the dimension that I have get from the blender. After we resize the form, I have to cut the form into pieces, and this form is not conductive because material to print the form out is not conductive. Then we have to spray the form first before we are inserting into the radiator form. And this is the sample that we have found from the workshops, and this is country radiator model 850, and the fin will be replaced by using the open cell form. The dimension for this country radiator is, for the length is 340 mm, width is 50 mm, and the height is 365 mm. The inlet and outlet diameter is 19.5. And the distance between the fins is 0.79 cm. And this radiator we haven't pulled out the fins yet, so the process will be due on next sense. This is the experiment setup or test rig setup, and the form that we want to replace is here. So this is the example setup of the test rig. This is the components that attach to the test rigs, and this is the fan is used to supply the airflow to cool down the radiator, and this is the radiator. The upper part has the components of pressure cap and the upper hose. This is the water tank. This water tank is used to supply the coolant to the engine or overflow of the coolant. This is the hose located at middle part, consists of valve and hose connected to the pump. And this pump is used to pump the coolant. Okay, that's all from my presentations. Thank you.